All right, this video is about chapter 3.3, which is about quadratic functions and their properties. And we've learned this before in Algebra 2, and we've talked about it with parent functions here, but we're going to get into a few details as part of our review. So the standard form of a quadratic equation would look like this. A would be the coefficient of the x squared term, B would be the coefficient of x, and C would be the constant. Some features about our graph of a quadratic: it's going to look like a parabola that's shaped like a U. It has an imaginary line. It's really, if you were going to put it on a graph, you should put it in dashed. That's called the axis of symmetry. It's not points that are actually plotted on the graph, but if you were to fold the graph on that as if it was a piece of paper, you would see that the left part of the graph would lay on top of the right part of the graph through that folding. Your vertex is either the higher or lower point. It's sort of the turning point. So if you have a parabola that opens up, that means that A is greater than 0. That means it opens up, and so your vertex is then your lowest point. If your A value in front of x squared is less than 0, then it's opening down, and so your vertex is going to represent a maximum point. The axis of symmetry is an imaginary line. It always passes through the vertex. It's a vertical line, so it has the equation x equals, and then the x that it equals is the x coordinate of the vertex. So let's say I said that this point was at 1, 7, then I would know that my axis of symmetry was x equals 1. If you just say 1, you will not get full credit because, again, it's important to appreciate that an axis of symmetry is a line, so it's not just a number. Okay, so we're going to use completing the square first to find the vertex and axis of symmetry if we're given a quadratic equation in standard form, which is what's happening here. So we've done completing the square before, but it's going to be a little bit different. And the reason it's going to be different is because we don't have an equation where this is equal to 0. We're going to do it all with everything staying on one side. So I'm going to factor a 2 out of these first two terms, and the reason is because, like we did before when I used completing the square, I want my coefficient of x squared to be 1. And so by doing so, inside of these parentheses, I can see that the coefficient here of x squared is equal to 1. I'm not going to factor it out of the plus 5. So it's worth taking a moment just to confirm that you agree that I have not mathematically changed what this equation's value is. I've just changed the way it looks. Now I'm going to complete the square just inside of here. Remember, the way we complete the square is we take our coefficient of x here, which is 4, we divide it by 2, and then it is squared. So now, because I've just added inside of these parentheses, I haven't just added 2 squared, which by the way is 4. I've added 2 times 4. In other words, I have added 8 to this equation. Well, when I do that, I've changed its value. So I need to balance it out. On the outside, I'm going to subtract 8 at the same time. So now, completing the square, this is 2 times, and again, the inside of these parentheses is what I have made a perfect square, just like we've done before. Remember, I keep this in this notation because this is what's going to come here and tell me how, I complete that square, or how I factor, excuse me. And so this is equal to x plus 2 in parentheses squared. What's on the outside is now minus 3. And so now I've put this into vertex form, and we've done this before. If I had my parent function of y equals x squared, it has shifted to the left 2 units and down 3 units. So this is my vertex. My axis of symmetry is an equation of a line, a vertical line that passes through this point. It would be x equals -2. Okay, let's do completing the square one more time, and then we'll try another method as well. So same idea. I again have a coefficient of 2 in front of x squared, so I'm going to factor that out. The plus 5 is still on the outside, the constant out there. I'm going to complete the square inside here. And I do that by taking the coefficient of x and dividing it by 2. That's -1 in parentheses squared. Now again, I have unbalanced this equation. I have added not only 1, but I've added 2 times 1. So I've added 2. So to undo that, I'm going to subtract 2 on the outside. I have now made what's in the parentheses a perfect square. It factors into x minus 1 squared. On the outside, I have plus 3. And so this tells me that my vertex is at 1, 3. My axis of symmetry, again, is x equals the coordinate of my vertex. Now, we also have an equation now, which you'll see up above here, that can help you find the x coordinate of your vertex from standard form. So that's a sort of useful way to do it as well if you are not going to be completing the square. So if I go back to y equals 2x squared minus 4x plus 5, then my formula for finding the x coordinate of the vertex is going to be x equals negative b over 2a. This comes out to be x equals 1. To get the y coordinate, I can now plug 1 in wherever I see an x. And when I do that, I get a y value of 3. So again, my vertex is 1, 3. So again, either way, you should be able to get the same values. Okay? If I am given my equation in standard form, it's very easy to move it over into, or I'm given it in vertex form, move it into standard form. I'm just going to watch my order of operations. Notice that when I square x minus 2, that's the same thing as x minus 2 times x minus 2, meaning I have to FOIL. So if I FOIL that out inside, I get x squared minus 4x plus 4. So this is the value of x minus 2 squared. Notice that this negative 3 on the outside will have to distribute in because of those parentheses. So this is negative 3x squared plus 12x minus 12 plus 4. And now I combine like terms to simplify. And this is the value of the same equation, but now in standard form instead of in vertex form. All right, so if I wanted to graph an equation, I want to gather the information that's helpful for me to do that. So one of the things that's helpful to know is just, is this going to open up or down? Because my a value is negative, in this case it's negative 3, I know that this is going to be opening down. If I want to find the vertex, I could complete the square, or I could use my new formula, x equals negative b over 2 times a. So in this case, x is equal to 1. To get the y coordinate, I'm going to plug 1 into this function. And when I do that, I get 4. So my vertex is going to be this point, 1, 4. My axis of symmetry is the vertical line, x equals 1, that goes through that point. Finding x and y intercepts. Your y-intercept in standard form is actually extremely easy. Remember, we find a y-intercept by making our x values 0. So I'm looking for y when x is equal to 0. But you'll notice when you do that, that these terms become 0. And so my y value is just equal to the constant at the end, which is c. So my y value of my y-intercept is that very easy to find. My y-intercept then is 0, 1. For my x-intercepts, I'm going to see where my y value is equal to 0. And I don't think that this factors, so I'm going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, this becomes negative 6 plus or minus square root of 48 divided by negative 6. This is negative 6 plus or minus 48 is 16 times 3. So I can bring a 4 outside. And I'm going to divide, because these are all divisible by negative 2. I'm going to divide them all by negative 2. So this is 3 plus or minus. Dividing by negative 2, we'll just switch it actually to like minus plus, which is the same thing. 2 square root of 3 over 3. Okay, so those are my x-intercepts. Unfortunately, they're not nice, easy points for me to plot, but I should see when I graph this that I have 2 x-intercepts. Let's talk in a second. We'll come back to this to see what it means when it says symmetry to plot additional points. So I'm going to go down to my graph, and I'm going to start to plot some of these things. So my vertex was at 1, 4. That's an important point. My y-intercept was 0, 1. I know that this opens down. What I meant by symmetry is, remember, my axis of symmetry is going right through the vertex, and it's a vertical line. So if I have one point that's 1 unit to the left, there's a matching point that's 1 unit to the right. So I know that the point in this case, 2, 1, is also on the graph of this parabola. And so I can use that to plot, and then I'll make this into, make sure it looks like a shape of a U. It needs arrows on the ends. I see it does cross the x-axis 2 times, which makes sense with what we said about our x-intercepts. So if I'm looking at this and I'm talking about domain, domain is my x values. All x values are appropriate and can be plugged into and evaluated at this function. My range starts at negative infinity, but it's going to stop. In this case, my vertex is my high point, so it's going to go up to 4 included. Increasing intervals, that's going to be happening on the left side of the graph here. That's from negative infinity to x equals 1, not included. Again, because at that point, the graph is neither increasing nor decreasing. And then it's decreasing on the right side, which is from 1 to infinity. Now, in this case, we have an absolute max. So I'm going to say I have a max of, I give the y value, which is 4, at, and I give the x value. So this is at x equals 1. And that's how I'll name this. Because this is opening down, I have a max. If this was opening up, I'd have a min. Okay. Okay, let's take a look at number 5. I'm just doing a quick scan to see if that's the one I think I'd like to do, which it is. Okay. So if I'm going to gather the same pieces of information, I can see that this opens up because my coefficient in front of x squared, which is a, is 1, and that's greater than 0, so it opens up. I know that my y-intercept is the c value, which is 0, 9. Okay. If I want to find my vertex, I can use x equals negative b over 2a, which comes out to be 3. And then to get the y value, I'm going to plug 3 into this function. And so when I do, I get 9 minus 18 plus 9, which is 0. So my vertex is at the point 3, 0. Okay. I know that my x-intercepts are going to be where y is equal to 0. And this actually looks like it's going to factor. X minus 3, x minus 3. So my x-intercept is at x equals 3. There's only one of them. So I know that this only touches the x-axis once. And notice that it happens to be the same point as my vertex. So my vertex is at 3, 0. My y-intercept is at 0, 9. Using symmetry, I know that because this is 3 units to the left, there's another one that's 3 units to the right. So that's the point 6, 9. And so I know that this is going to open up like that, and it only crosses the x-axis or touches the x-axis once, and that makes sense with what we've been looking at. So my domain, again, is going to be all real numbers, really, for all of these quadratics. My range, my y values are going to start at 0 and go up to infinity. Increasing, now my increasing intervals over here on the right, and so that's going to be from x equals 3 to infinity. Again, don't include that. The decreasing interval is on the left, which is from negative infinity to 3. In this case now, my absolute extreme, I'm going to have a minimum. So I say, state what I have. I have a minimum of, I give the y value, which is 0, at, and then I give the x value, which is 3. All right, I'll leave you to look at that one on your own. I'm going to show us how we can find an equation if we're given some information. In this case, we're given the vertex and a y-intercept. So if I know my y-intercept is 0, negative, or is at negative 3, I know I have the point 0, negative 3. And because I'm given the vertex, the easiest way to write this equation would be using vertex form. And so I'm going to put in, this is going to be my h, and this is going to be my k. So I know y equals a times x minus 1 squared plus negative 5, that's minus 5. So I'm very close to having my equation. The only thing I don't know is a. So what I'm going to do is I'm going to take the point that I have here, the other point, which is 0, negative 3, and I'm going to plug that in. If I plug in negative 3 for my y and 0 for my x, I know that that is another point that is on this graph, so it must make this true. And now I can solve for a. So this is negative 3 equals a times 1 minus 5. I'm going to add 5 to both sides, and I get that a equals 2. Sorry, Siri is confused. So therefore, I know my equation is y equals 2 times x minus 1 squared minus 5. Okay, so we were able to find those values. All right, finally, this one's a little bit more interesting because I'm not actually given the vertex this time. So in this case, I'm going to start with standard form. And one of the great things we know in standard form is that C is equal to the y-intercept, and I see that they gave me the y-intercept. So in this case, I actually know that C is already equal to 3. So I already know that I'm at this point. Okay, and now I have two other points, and basically I'm going to make a system of equations. I'm going to plug in the point 1, -4, and I'm going to plug in the point 2, -9. We'll have two equations and we'll solve for the two variables. So -4 is my y value, and 1 is my x value. And so I'm going to get -7 equals a plus b. So I have an equation with two variables, can't solve that yet. But I'm going to go get another equation. So I plug in my y value equals, now I plug in x equals 2. 4a plus 2b plus 3. So this is -12 equals 4a plus 2b. I'm going to divide everything by 2 just to make the numbers a little bit smaller. It might make my math a little bit easier there. And now you have a variety of choices, but I'm going to solve this for b. So b equals -6 minus 2a, and then I'm going to substitute. So remember, we have choices. You could use substitution, elimination. I'm going to use substitution. So wherever I see a b, I'm going to replace it with -6 minus 2a. And now I can solve for a. So this is minus a equals -1. So a equals +1. Solve for b. b equals -6 minus 2 times 1. So b equals -8. Now I have a, b, and c, so my answer is going to be my equation. Y equals a, which is 1, x squared, plus b, which is -8, x, plus c, which we found before was 3.